Okay, in our previous segments, we have talked about what the universe is composed of, and we said it was composed of matter, which was composed of quarks, it was composed of dark matter, and then it was composed of dark energy. Well, another way of viewing what the universe is composed of is by assuming that the universe is nothing more than fields. And so a field is a region of space. You should be very familiar with the magnetic field of a bar magnet. So this is the region of space that surrounds a bar magnet, and we call that the magnetic field. You should also be familiar with gravity and the gravitational field, so that if I was to take a pencil or something and let it go, it's going to fall straight down. If I take another pencil over here and I drop it, it's going to go straight down. So these arrows would represent the gravitational field that's inside this room right now. So scientists make up a field for each of the fundamental forces of nature, and then there's also a field that goes with each of the particles of nature, so that there is an electron field, there is a quark field in addition. So these are fields that go with forces, but there are also fields that go with particles. And then when you make a ripple in that field, so when the field starts to vibrate, that creates a particle. So if you have an electron field, and then the electron field begins to vibrate, it is going to produce an electron, a particle. So this is another way of viewing the universe. And then if you're interested in this, watch this video here, Instant Egghead 42, What is a Field? So that's going to explain it. And then you can also show how a field can create a particle by wiggling something. So there's a simulation over here that you can find on the internet. And then what you can do is you can make an electron wiggle up and down, and then you can see how the light waves are created. So electromagnetic radiation is created by wiggling an electron. So you might want to take a look at that simulation as well. So let's go through the fundamental forces as we know them today. So the first fundamental force is the gravitational force. And it is going to be the cosmic glue, because it's what's going to hold the universe together. So it's going to hold stars together. It's going to hold the planets in their orbits around the stars. It's going to hold galaxies together, galaxy clusters, galaxy superclusters. Anything that's really, really big, it's the job of gravity to hold it together. And in order to explain gravity, we need to use general relativity. So again, there's a picture of how the mass of a star bends space and time. So that's general relativity. So an object's mass is what causes gravity. And it exerts a gravitational force on another object when it creates a ripple in the gravitational field, which then interacts with the other object. So classically, we just said mass number 1, mass number 2, separated by a distance r, and then we had that formula for the force of gravity. Well, it's more complicated than that, because this one is going to create a ripple that this one over here is going to feel. And then when this one feels it, that's what the gravitational force is. So the ripple is going to be called an exchange particle. And for gravity, that exchange particle is going to be called a graviton. So I do want you to know what a graviton is. So when one object exchanges a graviton with another object, the two objects experience a force. So let's take a look at that in a little bit more detail. So I want you to watch this video on YouTube, medicine ball catch and throw on a skateboard. Okay? So what did you notice? When the guy takes the ball and he throws it, he moves backwards. Okay? When somebody throws the ball to him and he catches the ball, he moves backwards. So imagine that you had two people that were on roller skates. So you got this person here, which is on roller skates, and he's got a ball, and he's going to throw that ball over to this person over here who is also on roller skates. And this person is going to catch the ball. So when he throws the ball, he's going to move backwards. When he catches the ball, he's going to move backwards. So notice that by exchanging a particle, it exerted a force. Just as though you had physically walked over here and pushed on his cart, you exerted a force. So by exchanging the particle, you are exerting forces. So that's what we mean by an exchange particle. All right, now let's go to the second fundamental force that controls the universe. So the first one was gravity. The second one is the electromagnetic force. This is going to be the atomic glue. So it's going to hold the atom together, and it's also going to hold atoms together. So what do I mean by that? So that an atom consists of a positive nucleus and then negative electrons. And so opposites attract. So it's the electromagnetic force that keeps the electrons in their orbits around the nucleus to make an atom. But imagine that you've got two atoms. So if you got another atom over here and it's got its electrons, then what can happen is this electron here is going to feel the electromagnetic force caused by this atom over here, and it's going to be attracted to it. And then this electron is going to feel this one over here, and it's going to be attracted to it. So the two atoms are going to come together to make a molecule. So that the electromagnetic force holds individual atoms together, but it can also glue atoms together to make a molecule. Okay, what does it? So we just said it has something to do with electrical charges. So objects have electrical charge. There are two kinds of electrical charge. So you got positive electrical charge and negative electrical charge. Or you can think of matter having positive charge, and then its antiparticle has negative charge that goes with it. And so it's going to exert an electromagnetic force on another object, and when it does so, it's going to create a ripple in the electromagnetic field. So when it was gravity, it was a ripple in the gravitational field. This time, it's a ripple in the electromagnetic field. And that ripple is the exchange particle called the photon. And you should remember that because that's what light was. So electromagnetic radiation, X-rays, gamma rays, infrared, they're all come in little packets of light called photons. And that's the exchange particle. So that when this positive charge sees this negative charge, a photon is exchanged between the two, and that causes the electromagnetic force that's holding that thing together. All right, 2 down, 2 to go. So the last two fundamental forces of nature are nuclear forces. So they participate in the nucleus of the atom. So you got the strong nuclear force and the weak nuclear force. So let's first talk about the strong nuclear force. It's the nuclear glue. It's what's going to hold protons and neutrons together. So proton consists of quarks inside of it, and so does the neutron. So a proton is held together because of the strong nuclear force. But if you've got two protons, they can be held together by the strong nuclear force the same way that two atoms can be held together to make a molecule. So it's the same force is responsible for both situations there. Now, in the same way, gravity, mass causes gravity. Electrical charge causes electrical force. Color charge causes the strong nuclear force. Now, don't worry about it, okay? There are three colors, and they go with blue, red, and green. And when you add those three colors together, you get no color. You get the color white. But anyway, just know that color charge is the thing that is actually creating the strong nuclear force. It causes a ripple in the strong nuclear field, and then that ripple is going to be called a gluon. And there are 8 types of gluons, don't worry about that. But gluons are the strongest possible glue. And so that's the force that's holding the quarks together to make the nucleons, the protons and the neutrons. Then you got the weak nuclear force. So this one is the strangest of the 4 fundamental forces. Its job is to change protons into neutrons. But if you recall, a proton was made of quarks. So in this picture here, you've got a neutron changing into a proton. Now the neutron, if you were to look inside the neutron, you're going to see a up quark, and then you're going to see a down quark, and then also another down quark. So that's what a neutron is. But if it was to change into a proton would be an up, and then a down, and then an up quark. So notice that when the neutron changed into the proton, the down quark changed into an up quark. So that's an alternative way of saying what the weak nuclear force can do. It can change the identity of quarks. So by changing a down quark to an up quark, it changed the neutron into a proton. And then, do you notice that it also has to give off an electron so that this negative cancels this positive, so you end up with 0. And then the neutrino was another particle that's given off. Okay, so an object has weak charge the same way that an object has electrical charge. Electrical charge causes the electrical force. The weak charge causes the weak nuclear force. Another name for this is called flavor. And there are 2 types of it. And so this causes a ripple in the weak nuclear field, and that ripple is called a weak boson. So the point is, there are 4 fundamental forces, and each of the 4 fundamental forces has a particular particle that creates the force. So in the case of gravity, it was the graviton. In the case of electricity and magnetism, it was the photon. In the case of strong nuclear, it was the gluon. And now over here, it's the weak boson. So the point is, particles can be used to explain the fundamental forces of the universe. Okay, let's take a break, and when we come back, we're going to talk about the Higgs boson.